Okay, so we just did with logs that log 2 of 6 was equal to log 6 over log 2. And we used the idea that we learned from the sheet the other day, where you can take the log of both sides, use your log laws to expand completely, so this x could come out in front, and then you could get x by itself by dividing both sides by log 2. Now, what would happen if instead of taking the log of both sides, I took the natural log of both sides? If I can take the log of both sides, does it make sense that I could take the natural log of both sides? And all of your log laws that you have work for any base. So what can I do with this x? I can expand and bring that x out in front. And so we get x natural log of 2 equals natural log of 6. How could I get x by itself? Divide both sides by natural log of 2. So we get, in another box, I can write log 2 of 6 is equal to the natural log of 6 divided by the natural log of 2. Type that into your calculator and see if you get the same answer. Here, we'll pull it up. So, first of all, we did log 2 of 6. And now we're checking if log 6, here I'm going to use my fraction button, just so it looks nice. If log 6 divided by log 2 is the same answer, and it is. And now I'm going to check if natural log of 6 divided by, well, I want to use the fraction button again. Natural log of 6 divided by the natural log of 2 is also the same answer. It is. So then, just to complicate things, not complicate things, but to explore this a little bit further, let's take log of a different base. Should it work? So, pick a number that you feel has been underrepresented in math throughout your whole life. We're trying to make things better now. 19? Okay. So we're going to take log base 19 of both sides. Yeah, 19, it's a kind of a medium-high prime number. Right, you know where your log button is? Right above it or right below it, it says ln. The T83, you can't write the base. So in the T83, you would have to be able to change, if it was log 2 of 6, you could change it to this. Or you could change it to this with the natural logs or the logs. But this next one you won't be able to do with the T83. But the log laws still stay the same, right? I can expand this. That means this x could come out in front, and I would get x log base 19 of 2 equals log base 19 of 6, and divide both sides. Log base 19 of 6 divided by log base 19 of 2. And if I tried this on my calculator, I should get the same answer. So log base 19 of 6 divided by log base 19 of 2. And sure enough, we get the same answer. Now, because I could follow this process with any number, right? The log laws stay the same with every base. I could, I may as well just add our newest one that we found here in a red box. Log 2 of 6 is equal to log base 19 of 6 over log base 19 of 2. Because I could do this process with anything, I could have chosen any base when I started to solve this and went through my log laws, and the same thing happens every single time. We have a rule. It's the fourth formula that you see up on the board over there. They have a little proof of it here, but it's called the change of base theorem, and it's on the top of your next page. And it says right here, I'll rewrite it so you guys can see it bigger. It says, and I'll use the same letters that we have on our formula sheet, log A of m is equal to log B of m over log B of A. So some things to notice, okay? The A that I circled in purple here is also over here. The M that I circle in green here is also over here. But the B is only on the right-hand side of this formula. And so that B means that it can be anything. You could choose any base you wanted. Of course, if you're trying to figure out, right, especially, this was especially important before the newer calculators had the base built into it. So if you were trying to figure out 3 to what power is 17, or log 3 of 17, well, you would almost always change the B either to a base 10, your common log, because that you could type in quickly into your calculator, or a base of E, which is your natural log, because that you could type into your calculator quite easily. But now you can type this into your calculator as well. So it becomes like another formula that you can manipulate and you can simplify from changing from the right-hand side to the left-hand side. So if you have a log divided by a log, if you see that in an equation, you can say, hey, I can use my change of base theorem and change it back to a single log that way.
The only value the base cannot be 1.
That's right. Yeah, the base can't be 1, so your base has to be something other than 1. Okay, let's look at example 1. It just wants you to approximate the value of these. They're pretty straightforward. You can just type it in, but it says also write the related exponential expressions. So for log 5 of 50, if you let x equal log 5 of 50, then this is really asking 5 to what power is 50. And if we had to estimate this without our calculator, between what two numbers would it be between? 2 and 3, because 5 squared is 25, 5 cubed is 125. If we wanted to figure this out, right, we can just do, what were the numbers, 50 and 5? We can just do log 50 divided by log 5. So there I use the change of base theorem instead of using, this way everybody's calculator can get that. And sure enough, it's between 2 and 3. So that little estimation beforehand is good because it lets you know, hey, when I plug in this in, I should get an answer between 2 and 3. And it is 2.431. Same thing for the second one, log 8 of 6. If we let x equal log base 8 of 6, that means 8 to what power is 6? What should this one be between? What two whole numbers? 0 and 1. Because 8 to the 1 is 8, and 8 to the 0 is 1. And so if we check this out, if we try this on our calculator, well, this time I'm going to use the natural log. Natural log of 6 divided by natural log of 8. Oops. 0.862. Should practice doing approximation symbols as much as possible. So it's pretty straightforward. Okay, we're not going to do these questions right now, but 3, 4, and 5.